Okay.
Yes, sir.
Chalo. Let us try to come to the next topic better. Circuit analysis. And how the currents have been connected when they are connected in series, parallel. How do you take that relations all basically? Okay, na?
Yes, sir.
Sure. First one, you potential difference distribution. Okay. So we are talking about your potential difference distribution. Okay. Let's see if this is circuit for you. And here we are having positive terminal, negative terminal like this. And this is some resistance of your R1. This is some resistance R2. And your applied potential is capital V. So this is a positive terminal. This is a negative terminal. So this is also your positive. This is your negative. This is your positive. This is your negative. And potential across this one is, say, for example, V1. And potential across this one is, say, for example, V2. Okay, na?
Yes, sir.
R1 kada potential enta V1, R2 kada potential enta V2,
V2.
applied potential enta V.
V.
So దీంట్లో కరెంట్ అయిపోయింది అనుకో. సో ఇక్కడ కూడా కరెంట్ అయినా, ఇక్కడ కూడా కరెంట్ అయి, ఇక్కడ కూడా కరెంట్ అయి, ఇక్కడ కూడా కరెంట్ అయి. అంటే there is no division of a current. ప్రతి చోట కరెంట్ సేమే కదా, isn't it? So
Yes,
I
sir.
is same. I is same, isn't it? So I is same in all resistors. In all resistors. So if there is no division of a current, it will be what combination better? Series combination.
Yes, sir.
Okay. So I can say that if there is no division, if there is no division of current, it is called what combination? Series combination. Okay, na?
Yes, sir.
Now should this potential is directly proportional to your R beta from Ohm's law. From Ohm's law, we know the formula V is equals to I into R, nana. So I can say that V is directly proportional to the resistance R.
Yes, sir.
Okay. Now if I need to calculate the potential V1, so V1 I calculate some V1 is equals to V1 kada resistance enta undi R1 into total potential enta V divided by R1 plus R2. ఏం రాసిన చూడండి, V1 కావాలంటే ఏ రెసిస్టెన్స్ ఎలా అయితే కరెంట్ పోతుందో ఆ రెసిస్టెన్స్ రాసుకున్నాను ముందు ఇంటూ టోటల్ పొటెన్షియల్ డివైడెడ్ బై R1 ప్లస్ R2. అదేవిధంగా V2 కావాలనుకో, V2 కావాలంటే టోటల్ పొటెన్షియల్ V ఇంటూ రెసిస్టెన్స్ ఆఫ్ R2 డివైడెడ్ బై యువర్ R1 ప్లస్ ఆఫ్ యువర్ R2. That will be the value of your V2. Clear?
Yes, sir.
Any doubt in this one?
No, sir.
V is equals to your R1 into V divided by your R1 plus R2, and V2 is equals to your V into your R2 divided by R1 plus R2. అంటే ఇప్పుడు V1 కావాలంటే దాని రెసిస్టెన్స్ యాజ్ ఇట్ ఈస్ టోటల్ పొటెన్షియల్ ఇంటూ R1 ప్లస్ R2. అర్థమైందా?
Yes, sir.
ఇప్పుడు ఇది V1 కావాలంటే ఏం చేయాలి, ముందు దాని రెసిస్టెన్స్ రాసుకోవాలా, దాంతో ఎక్కడ ఇది రెసిస్టెన్స్ ఉందో దాంతో రాసుకోవాలా VR1, దాని తర్వాత టోటల్ పొటెన్షియల్ రాసుకొని డివైడ్ బై యువర్ టోటల్ రెసిస్టెన్స్. అదేవిధంగా V2 కావాలంటే R2 ఇంటూ టోటల్ వోల్టేజ్ డివైడెడ్ బై R1 ప్లస్ R2.
Yes, sir.
Clear?
Yes, sir.
So I hope you got an idea how to calculate the potential differences.
Yes, sir.
Next one. Current distribution. కరెంట్ డిస్ట్రిబ్యూషన్ అంటే మన దగ్గర రెసిస్టెన్స్ ఎట్లా ఉందనుకో, ఇది టెర్మినల్ ఏ, ఇది టెర్మినల్ బి, ఇది రెసిస్టెన్స్ ఆఫ్ యువర్ R1, ఇక్కడ వచ్చేసి రెసిస్టెన్స్ ఆఫ్ యువర్ R2. ఓకేనా?
Yes, sir.
సో ఇక్కడ నుంచి సమ్ కరెంట్ వస్తుంది అనుకుందాం. దిస్ ఇస్ యువర్ I. ఈ జంక్షన్ కార్డ్ రాగానే ఏమైపోతుంది? డివైడ్ అవుతుంది. సో దీంట్లో కరెంట్ I1 అనుకుందాం, దీంట్లో కరెంట్ ఎంత? I2. అంటే R1 లో కరెంట్ ఎంత? I1. R2 లో కరెంట్ ఎంత? I2. ప్యారలల్ ఏం సేమ్ ఉంటుంది అన్న? పొటెన్షియల్ సేమ్.
Yes, sir.
V is same. If there is a division of current, it will be called as parallel combination. If there is division of current, then take it as parallel. Take it as what, beta? Parallel. Okay.
Yes, sir.
Now from Ohm's law, we know the relation V is equals to I into R. V is equals to I into R, and I is equals to how much for me, beta? V by R. Potential same unte, how is the current related to resistance, beta? Current is inversely proportional to resistance because potential constant kada. V is your constant, so
Yes,
I is
sir.
inversely proportional to your resistance. So at that time, what you do is, whatever the current you are taking, I1. So this I1 will be equal to how much for me? I can write I is equals to your I1 plus of your I2 from the Kirchhoff first law. So incoming current must be equal to your outgoing current. Now if I need the value of your I1, if I need the value of what, beta? I1. See what I can write here? I1 is equals to, see how am I writing? ఈ I1 రావాలంటే ఈ I1 కి ఆపోజిట్ రెసిస్టెన్స్ ఎంత అవుతుందో అది రాసుకో ముందు. దట్ ఈస్ నథింగ్ బట్ అండ్ టోటల్ కరెంట్ ఎంత? I. సో I1 కావాలన్నప్పుడు టోటల్ కరెంట్ రాసేసుకొని ఈ I1 కి ఆపోజిట్ రెసిస్టెన్స్ ఎంత ఉంది రైట్ నౌ? ఇక్కడ R2 డివైడెడ్ బై యువర్ R1 ప్లస్ ఆఫ్ యువర్ R2. సో దిస్ విల్ బి ది వాల్యూ ఆఫ్ యువర్ I1. దిస్ విల్ బి ది వాల్యూ ఆఫ్ యువర్ I1. అదే విధంగా I2 కావాలనుకో, I2 is equals to your total current. I2 కి ఆపోజిట్ రెసిస్టెన్స్ ఎంత ఉంది? R1. So this will be your R1 divided by your R1 plus of your R2. So this will be the value of your I2. So I2 is equals to your I into your R1 divided by R1 plus of your R2. Clear, beta?
Yes, sir.
Any doubt in this one?
No, sir.
Sure. Next one is point potential method. Point potential method. This is also one of the easy way to calculate the resistances and potentials better. So we are talking about potential kabatti. Like say for example, this is a given circuit right now for me. Negative terminal, positive terminal, and here is one positive terminal and negative terminal. And there is a resistance in between them, beta, something here. And there is a positive terminal and negative terminal, like this. And here this one is connected to this one like this. And this one is connected to this one like this. Okay. So there is a flow of a current. This resistance ఉంది అనుకుందాం. దీని resistance వచ్చేసి 2 ohms. ఇది వచ్చేసి 10 volt. Okay. ఇక్కడ resistance ఉందన్న. So there is one resistance in this one. And there is also one resistance in this one. Okay. So ఈ resistance వచ్చేసి for example 2 ohms. ఈ resistance వచ్చేసి for example 4 ohms. ఇది battery of 2 volts and this is a battery of your 4 volts. Okay. And there is a flow of a current. ఈ junction నుంచి current పోతుంది. Like say here there is a current of your I1 and here there is a current of your I2 and here there is a current of your I3. Okay. అంటే దీనిలో వచ్చేసి కరెంట్ I3, ఇందులో కరెంట్ వచ్చేసి I1 and ఇందులో వచ్చేసి కరెంట్ I2. Is that circuit diagram clear?
Yes,
How many
sir.
cells we are having, beta? Cells ఉన్నాయి, రెసిస్టెన్స్ ఉన్నాయి. ఇప్పుడు నాకు వాడు పొటెన్షియల్ కనుక్కోమన్నాడు అనుకో, లేకపోతే కరెంట్ కనుక్కోమన్నాడు అనుకో. సో వీ కెన్ డైరెక్ట్లీ అప్లై రైట్ నౌ ఎట్ దిస్ జంక్షన్. ఇది O అనుకుందాం. Isn't it? లేకపోతే I don't know that junction, I'm giving it some name X. ఇది positive negative కాబట్టి this is a positive terminal, this is a negative terminal. So obviously here there will be a 0 volt. So here it will be equal to how much, beta? 10 volt. and here if I'm taking some x volt, so at this point the potential will become how much beta? X minus 2 volt. ఎందుకంటే ఇక్కడ పొటెన్షియల్ కావాలి. ఈ పాజిటివ్ కి x ఉంది, నెగటివ్ కి minus 2 ఉంది. సో x minus 2. అదే విధంగా చూడు, this is a positive terminal, this is a negative terminal. అంటే here it is right now x and here it is negative minus. So this junction will be x minus 4. అంతే కదా. సో ఇక్కడ నెగటివ్ టెర్మినల్ అంటే ఇది -4 and if this positive is connected to some x potential, I don't know because these two are commonly connected కాబట్టి I have given some x potential. ఇది negative potential కాబట్టి I am assuming it as 0. So obviously plus card it will be equal to how much for me? 10. Okay na?
Yes sir.
Now from the x, what is the current? I1, I2 and I3 are happening better. They are going out kabatti I can write here I1 plus of your I2 plus of your I3 will be equal to how much? 0. Sum of all the outgoing currents from the junction must be equal to 0. Kirchhoff law, Kirchhoff first law. Antena?
Yes sir.
Kirchhoff first law. Sum of your all the outgoing currents in a given circuit must be equal to your 0. So how do you write the current beta? As I is equals to your V by R. So if I'm writing I1, and from here to here beta. So if I'm writing the value of your I1, so I1 if I'm writing, see this given condition from here, I can use this relation. Okay, I1 means what? X to x minus 2 I am going. Another. So I can write here I1 will be equal to your x minus 2. This is potential divided by resistance of this one. From here to here, what is the potential right now? I1 current. Resistance is nothing but 4 plus I2. I2 current is in this one. So how to write the value of I2? The potential here is how much for me beta? X. And here the potential is how much for me or 10. So there is a flow of current in this one is how much for me over I2. So I2 I can write as of your x minus the potential here is nothing but 10 divided by resistance is right now 2 plus I3. I3 means this one. So how much it is? X minus 4, isn't it?
Yes
it is
sir.
x minus 4, x minus 4 divided by your 2, isn't it? So that must be equal to how much for me? 0.
0.
అవునా కదా. సో ఇది ఎంత అవుతుంది చెప్పు. అలా నెక్స్ట్ స్టెప్
LCM.
ఎంత అవుతుంది? ఇది 0 కదా ఇక్కడ.
అవును.
ఇది మొత్తం ఏమైపోతుంది? ఎల్సిఎం తీసుకుంటే ఇటు సైడ్ మొత్తం ఏమైపోతుంది? 0.
అవును.
ఎలా రాయొచ్చు నెక్స్ట్ స్టెప్?
x minus 2 plus 2x minus 20 plus
2x minus
20 plus 2x minus 8.
2x minus 8 is equals to
0.
అంతేనా?
Yes sir. x equal to 6 వస్తుంది.
అంతే కదా.
Yes sir.
ఏమైనా క్యాన్సిల్ అవుతున్నాయా?
x equal to 6 వస్తుంది.
x is equals to 6 volts. అంటే this x potential what I have got is nothing but 6 volts. So now I can calculate the value of I1. So therefore I1 will be equal to how much beta? 6 minus 2 divided by 4. 6 minus 2 is how much?
Yes sir. 6 minus 2 is 4.
4 by 4 that is equals to 1 ampere. అంటే I1 current which has been flowing in this one, the 4 ohm resistance ఎంత? 1 ampere.
1 ampere.
I2 will be equal to how much beta? X minus 10. X value is how much? 6. 6 minus 10 divided by 2. అంటే 6 minus 10 అంటే ఎంత? Minus 4 divided by
minus 2.
That means minus 2 amperes. అంటే our assumption is wrong that I2 direction is reverse చేసుకోవాలి మనం చేసిన డైరెక్షన్ డౌన్వర్డ్ ఉంది, బట్ we got a negative current కాబట్టి there is a flow of a current in the opposite direction. Yes, the current will flow from 0 to x but not from x to 0.
Yes
okay
sir.
అదే విధంగా I3 will be equal to x minus 4. That means 6 minus 4 divided by 2. 6 minus 4 is how much?
1.
So this is a 2 divided by 2, that is equals to 1 ampere. Positive. That means I3 value is positive. So what will be the total current beta? I1 plus I2 plus I3 must be total current. Na?
Yes sir.
I1 ఎంత ఉంది? 1. This one is plus minus 2. This is plus 1. That is equals to your I. So what is the total current flowing in the circuit?
Sorry, sir.
What is the net current I am getting better? I1 is 1, I2 is -2, I3 is nothing but 1.
0.
So net current is becoming for me 0.
Yes,
from
sir.
I1 plus I2 plus I3 will be equal to 0. It is getting proved right now here. Got it?
Yes, sir.
Sure. So got an idea how to do the point potential method?
Yes, sir.
By our own analysis, what we are doing is for the higher potential of a battery, at one end I am taking 0 volt, at another end I am taking it as X. Then accordingly I have distributed the potential and I am applying the Kirchhoff law. Clear?
Yes, sir.
Sure. Next one. Ninth one. Combination of resistors. Combination of resistors. What are the different combination of the resistors we know better? First one is your series combination.
Series parallel.
So in series, what I told you better, there is no division of current.
Yes, sir.
If you see that if there is no division of current, if there is no division of current, that will be the series combination. Okay, something like this. This is your R1, this is your R2. So R effective ఎంత అవుతుందన్న? R effective will be equal to your
R1 plus R2.
R1 plus R2. గుర్తుంది కదా?
Yes, sir.
Sure. Next one. Number 2, parallel combination. What I told you in parallel combination, there is a division of your current. అవునా కదా?
Yes, sir.
If there is division of current, that will be called as of your parallel combination. Okay?
Yes, sir.
So let me give you one example in this one. Like say, this is R1, this is R2, this is a terminal A, this is a terminal B. Isn't it? So potential across your A and B will be equal to how much? Some potential B. In parallel, what is the same beta? Potential kada?
Yes, sir.
And how do you write the effective
Potential.
resistance beta? 1 by R effective will be equal to your 1 by R1 plus 1 by R2. గుర్తుందా? అంటే
Yes, sir.
R
Yes.
effective will be equal to your how much for me? R1 into your R2 divided by R1 plus R2.
Yes, sir.
Isn't it? అదే విధంగా ఇంకోటి అనాలిసిస్. ఇది సర్కిల్ అనుకుందాం. ఇది సెంటర్. ఇక్కడ నుంచి ఇక్కడ వరకు ఒక రెసిస్టెన్స్, ఇక్కడ నుంచి ఇక్కడ వరకు ఒక రెసిస్టెన్స్, మళ్ళీ ఇక్కడ నుంచి ఇక్కడ వరకు ఒక రెసిస్టెన్స్. ఓకే, అండ్ హియర్ దెర్ ఈస్ వన్ పాయింట్ A and there is one point B. Okay, now this is the resistance of your R1, this is the resistance of R2, this is the resistance of R3. You see, if you carefully beta, the circle which is in outward, if this is a potential B, here also the potential will be B, here also potential B, so here also potential B, here also potential B, here also potential B, here also potential B, because no resistance is there. So everywhere on the wire, the potential will be equal to how much beta? Same.
Yes, sir.
Clear?
Yes, sir.
So now here the potential is how much for me or A. So from the A, if there is a flow of a current, now see carefully. If there is a flow of your current, that means we are assuming that this is connected to a positive terminal and this is connected to a negative terminal. So when there is a flow of a current, the moment the current comes here, it will get divided. The moment it gets divided, they will be seeing the current here as I1. here as of your I2, and here as of your I3. So everywhere there is a division of a current now, beta.
Yes, sir.
So I can, what I'll do is, between the point A and between the point B, I'm writing the point A and point B. చూడు పాయింట్ ఏ అంటే ఇది ఏ అయితే ఇది కూడా ఏనే కదా జంక్షన్ కాడ.
Yes, sir.
సో ఏ అండ్ బి మధ్యలో ఒక రెసిస్టెన్స్ ఉందా, ఇది.
Yes, sir.
మళ్ళీ ఏ అండ్ బి మధ్యలో ఒక రెసిస్టెన్స్ ఉందా,
Yes, sir.
మళ్ళీ ఏ అండ్ బి మధ్యలో ఒక రెసిస్టెన్స్ ఉందా.
Yes, sir.
ఏమైనా మొత్తం ఇది
More parallel connection.
R1, R2, R3, all of them are in parallel combination,
Yes, sir.
isn't it? So 1 by R effective will be equal to your 1 by R1 plus 1 by R2 plus 1 by R3. What an idea?
Yes, sir.
Sure. Please do. ఇక్కడ resistance ఉందనుకుందాం, ఇది junction, and here there is one resistance, and here there is one resistance. Okay, so దీని resistance వచ్చేసి R, దీని resistance వచ్చేసి R, దీని resistance వచ్చేసి R. Okay,
Yes, sir.
ఇక్కడ కూడా రెసిస్టెన్స్ ఉందనుకోండి, దీని రెసిస్టెన్స్ ఎంత, క్యాపిటల్ R. ఓకేనా.
Yes, sir.
R effective ఎంత అక్రాస్ దిస్ సర్క్యూట్. ఓకే, ఇది మొత్తం బయట ఒకటే వైర్ ఉందా చూడు ఒకసారి.
అవును సార్.
అంటే ఇక్కడ పొటెన్షియల్ ఎంత అయితే ఉంటుందో ఇక్కడ కూడా అంతే ఉంటుందా, ఇక్కడ కూడా అంతే ఉంటుంది, అవునా కదా. ఇఫ్ దర్ ఈస్ సమ్ ఎక్స్ పొటెన్షియల్ ఇయర్, ఈ వైర్ మొత్తంలో ఎక్స్ పొటెన్షియలే కదా, ఎందుకంటే మధ్యలో రెసిస్టెన్స్ ఎక్కడ లేదు, అవునా కదా. సో హియర్ ఇట్ ఈస్ హౌ మచ్ ఫర్ మీ యువర్ ఎక్స్. వాట్ ఐల్ డూ ఇస్ ఐల్ టేక్ ఈవెన్ వన్ మోర్, ఒక రెసిస్టెన్స్ ఇక్కడ తీసుకుందాం. ఓకే,
yes sir. Yes sir.
సెంటర్ కార్డ్ అయితే పాయింట్ ఏ అనుకుందాం, ఇది వచ్చేసి బి అనుకుందాం. Now need the effective resistance across your A and B. R across your A and B is how much? Okay, so what I'll do is, first I'll write the resistance A outside, and here I'll write the resistance B. Now see very carefully, A and B మధ్యలో ఒక resistance ఉందా, A and B మధ్యలో ఒక resistance ఉందా. So I'm writing that resistance here like this. Okay, A and X మధ్యలో ఒక రెసిస్టెన్స్ ఉందా, అంటే మధ్యలో X ఉంది కాబట్టి what I'll do is, first I'll write one X value also in between this one. So A and B, A కి X కామన్ కదా, అంటే సెంటర్ ఎక్కడ నేను X తీసుకున్నాను, అవునా కదా. B కి కూడా X ఉంది కదా, చూడు. For this B there is a X connection, for this B there is an X connection, for this A there is an X connection. Now tell me, between A and X there is one resistance, beta.
Yes sir.
Between A and X there is one resistance, so I can write one resistance here right now. Between X and B there is one resistance, so between X and B also one resistance, isn't it?
Yes sir.
Then ఇంకెక్కడ ఉందా చూడు, ఇక్కడ కూడా ఉంది one more resistance. See, if you see it carefully, this one, A and X, one more resistance.
Yes sir.
So if I'm writing here right now, A and X, one more resistance like this, isn't it? B and X, one more resistance, this one.
Yes sir.
So this will be your B and X, one more resistance. Then between A and B there is one resistance directly.
Yes sir.
చూడు, A and B మధ్యలో రెసిస్టెన్స్ ఉంది డైరెక్ట్లీ. See, between A and B there is one resistance. ఇక్కడ చూడు. అవునా?
Yes, sir.
అన్నీ వచ్చేసాయా?
Yes, sir.
No. Write the resistances for everyone. So this is your R, this one is your R, this one is your R, this one is your R, and this one is your R. Now see carefully. These two will be which combination? Parallel.
Yes, sir.
These two are also in which combination? Parallel. One ఒకదాని పైన ఒకటి ఉన్నాయి కదా. అంటే parallel అయితే effective ఎంత అవుతుందన్న?
1 by R plus 1 by R.
So this is also R by 2.
Yes, sir.
Any doubt?
No, sir.
So now between A and X, ఇది X, ఇది A. A and X మధ్యలో రెసిస్టెన్స్ ఎంత? R by 2. అదే విధంగా X and B మధ్యలో ఒక రెసిస్టెన్స్ ఎంత? R by 2. Okay?
Yes, sir.
A and B మధ్యలో ఒక రెసిస్టెన్స్. ఇది వచ్చేసి R. ఓకేనా?
Yes, sir.
Now see, assume that this A is connected to some positive, B is connected to some negative. When there is a flow of a current, wrong divide అవుతుంది కదా. So there is a current flowing in this one as of your I1 and this one as of your I2. అవునా? So R by 2, R by 2 a combination. This R by
Series.
2 and R by 2 series combination. So I can write one resistance here right now. R by 2 plus R by 2. Enta R. Down is also your how much for me or R. This is a terminal A. This is a terminal B. These two are in which combination? Parallel. So R effective across A and B will be equal to how much for R by 2. Antena?
Yes, sir.
Any doubt?
No, sir.
Sure. Next one. Wheatstone bridge. గుర్తుందా?
Yes, sir.
When more than two resistors have been present in a given circuit, అంటే ఒక resistance ఇక్కడ, and here it is one more resistance, and here there is one more resistance, and here there is one more resistance, and middle there is one more resistance like this. Okay, and this is connected to some terminal A, and this is connected to some terminal B. Okay, like say this is your R1, this one is your R2, this one is your R3, this one is your R4, this one is your R5. Okay, condition is that if R1 R3 is equals to your R2 R4. Okay,
balanced Wheatstone bridge.
అంటే R1 by R2 అంటే అర్థం ఏంటి? R1 by R2 is equals to your R4 by your R3. అంతే కదా?
Yes, sir. Yes, sir.
So at that time R5 will become ineffective. Then R5 will be ineffective.
Yes, sir.
So remove it. So remove it and solve the problem and solve problem in general manner. అంటే series parallel తీసుకొని. Okay na? Isn't it?
Yes, sir.
If you remove it overally, so we'll be getting one resistance right now here, and one more resistance here, one more resistance here, one more resistance here. This is a terminal B, and this is your terminal A. And this will become for me R1, this will become for me R2, this will become for me R3, this will become for me R4.
Yes, sir.
Isn't it? So at a time R1 and R2 will be which combination better? Series, because there is no division of current. The R1 and the current both R2 lagte potundi.
Yes, sir.
And R4 and R3 will also be in the series. But overall these two, until this can be something like this parallel. This will become for me R1 plus of your R2, and down it will become from your R3 plus of your R4. This is a terminal B, this is a terminal A, isn't it? So R effective will be equal to how much better? R effective will be equal to your. Again, these two are in which combination? But if you see it very carefully, R1 plus R2 and R3 plus R4. This is which combination? Parallel combination. So parallel combination ante 1 by R effective will be equal to your 1 by R1 plus of your R2 plus this one is 1 by R3 plus of your R4. Antena?
Yes, sir.
Now we can from this one simplify, we'll get the value of R effective. Cheskuntaga?
Yes, sir.
Any doubt?
No, sir.
A question is Sanjayana?
Yes, sir.
Chudo, sir. If there is one resistance like this, and 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 this is a terminal B, and this is a terminal A. I need the resistance across A and B is equals to how much? Values are, this one is 8 ohms, this one is 4 ohms, this one is 2 ohms, this one is 4 ohms, and this one is 5 ohms.
Sir, ఒక్కసారి పైన స్క్రోల్ చేస్తారా?
If R1 by R3 or R1 by your R2 is equals to R4 by R3, then R5 will be what? Ineffective.
Okay, understood.
So we can remove it and we can solve the problem in your general manner.
Yes, sir.
Judo. 8 by 4.
Yes, sir. Balance condition.
Balance condition అవుతుందా?
Yes.
And if it is balanced condition, this can be redrawn something like this.
Yes, sir.
8 plus 4.
12.
This will be your 12. Down 4 plus 2.
6.
This is 6 ohms. This is a terminal B. This is a terminal A. So effective will be equal to how much better?
3 by 12. 12 by 3, 4.
So this will be equal to 12 divided by 6. This is a terminal B. This is a terminal A. So resistance across A and B will be equal to 12 into 6 divided by 12 plus 6. 12 6
Yes, sir.
12 6
72.
72. 12 plus 6.
18.
18. So what will be the answer?
4.
Chinda?
Yes, sir.
What an idea?
Yes, sir.
దీని ఇట్లా కూడా ట్రయల్స్ చేసుకోవచ్చు నాన్న చూడు సార్ లిసన్ కేర్ఫుల్లీ దిస్ కెన్ బి ఒకవేళ డయాగ్రామ్ ప్రాబ్లమ్ ఇట్లా ఇచ్చాడు అనుకో దెర్ ఇస్ ఎ రెసిస్టెన్స్ హియర్ దెర్ ఇస్ ఎ రెసిస్టెన్స్ హియర్ అండ్ దెర్ ఈస్ సమ్ రెసిస్టెన్స్ ఈవెన్ హియర్ రైట్ నౌ దిస్ ఇస్ a terminal B and this is your terminal A. Okay?
Yes, sir.
ఇక్కడ same question. Let's say this is 4 ohms, this one is 8 ohms, this one is 5 ohms, this one is 2 ohms, this one is 4 ohms. 8 and 4 మధ్యలో 5, 4 and 2 మధ్యలో 5. అంతేనా? ఇది సమ్ పొటెన్షియల్ X అనుకుందాం, ఇది సమ్ పొటెన్షియల్ Y అనుకుందాం.
Yes, sir. Yes, sir.
Isn't it? So something like it is X and this one is Y. So you can rearrange like this. ఇట్లా ఇచ్చినా కూడా సో పిల్సన్ బ్రిడ్జ్ అనే కాన్సెప్ట్ తీసుకోవాలి. ఓకేనా?
Yes.
Any doubt?
No, sir.
Clear?
Yes, sir.
Sure. I'll send you today some assignments related to the current electricity beta. You try to do that one and keep the full stop. In tomorrow's session of your class, we'll try to talk about the restarts in the infinite ladders, power concept relation, okay, na bulb problems, conversions of galvanometer, meter bridge, potentiometer, ఇవన్నీ చేద్దాం నెక్స్ట్ క్లాస్ లో.
Meter bridge.
మీటర్ బ్రిడ్జ్ అయితే ఇప్పుడు అయింది కదా.
Okay, sir.
Isn't it? Potentiometer, meter bridge.
Yes, sir.
నేనైతే ఇప్పుడు Wilson bridge చెప్పాను, సారీ మీటర్ బ్రిడ్జ్ చెప్పలేదు. టుమారో విల్ ట్రై టు డూ ద మీటర్ బ్రిడ్జ్ ఇన్ ద క్లాస్.
Yes, sir.
ఓకేనా? అర్థమైందా?
Yes, sir.
షూర్?
Yes, sir.